Welcome everyone to this YouTube Hangout session. My name is Himanshu Tyagi. I'm an assistant professor in the Electrical Communication Engineering Department of the Indian Institute of Science. Today you will get to know about what kind of work we do here in this department. What are the various research areas that our faculty work on, and hopefully we'll get to hear what questions you have about the admission process and about the department. We'll start with an introduction to the department by the department chairman, Professor KVS Hari. Then we'll have short 2-minute introduction to different research areas by various faculty that are present here. And finally, we'll take up your questions. So let me start by passing on the mic to Professor KVS Hari, and he'll start by introducing the department.
Thank you, Dr. Himanshu Tyagi. Good afternoon and welcome to this session. I'm KVS Hari. I'm a faculty member in this department. So let me start by introducing our department. If you see the first slide of my presentation, you will notice that we were established in 1947, and we have spent about 7 decades in the field of communication, signal processing, microelectronics, microwaves, and photonics. So our goal is to pursue excellence. So if you look at our next slide, the research areas which we are currently pursuing, if you start on the top, it's communication, networks. We do interdisciplinary research, microelectronics, nanoelectronics, RF, microwaves, photonics, and signal processing. So the nature of work and research and other activities, industrial interaction and applied research will depend upon individual faculty interests, as well as sometimes interest from the students themselves, who may want to pursue something and they trigger the faculty's interest. And we are open to listening to students' views and working together and pursue a new field, which need not be listed here. Next slide. So the themes. Okay. So the faculty composition. Basically, we have about 11 professors, 5 associate professors, 7 assistant professors. We have 3 principal research scientists. We have scientific officers, visiting professors, and associate faculty. So associate faculty members are basically faculty members from other departments in the institute who are attached to ECE department. For example, we have 1 associate faculty member from the Center for Neuroscience, and there is interest in this department of doing neuroscience and bioengineering related work. The faculty have a very rich experience and have graduated from the top schools in the United States and other parts of the world. So if you look at the next slide, you will see that faculty have graduated from Brown, Carnegie Mellon, Caltech, Cornell, IISc, IIT Kanpur, MIT, Penn State, Princeton, Purdue, Sheffield, Stanford, Texas A&M, TFR, Maryland, Michigan, Southern California, UT Austin, University of Washington. So you can be assured that you will be interacting with people who have experienced different systems, the Indian systems and the non-Indian systems, and universities which are at the forefront of technology and research globally. The faculty members are very active in research and are very well recognized globally and nationally. This slide gives you an indication of the recognition by various academies in the country, like fellowships of national academies. We have all 19 fellowships, that is faculty members hold multiple fellowships of different academies in the country. We have the World Academy of Sciences Fellowship. We have IEEE Fellowship, which is an international society. Faculty members are editors of various top journals research journals, which are basically IEEE journals, CIAM, Elsevier, Springer, etc. We have a lot of faculty members who have won awards, like the Inspire Fellowship, J.C. Bose Fellowship, Swarna Jayanti Fellowship, and so on and so forth. So this basically indicates that how active our faculty members are. We are as good as any top university in the world in this field of electronics and communication engineering. So the students, the next slide indicates the composition of the students. So typically you will see that the department has a lot of students who are pursuing their PhD, which includes research students who are regular students, as well as people from industry and students who have working in academic institutions, that is, who are faculty members who want to pursue their PhD, and external registration program students who are basically from R&D labs and industry. But the core, you can see that the bulk of the students are PhD students. And then we have these MTech students. We have MTech in communication networking, networks, signal processing and microelectronics. And then we have MTech research, which is the research program. I'll give you more details in the subsequent slides. So together, faculty, students, and even project staff, we publish various findings, research findings, which we conduct. We are very active, and this is a snapshot of the Google Scholar citation index of all the publications of all the faculty members so far. So we have a very healthy H index, which is very significant in terms of the scientometrics. The snapshot of the activity of the last 5 years, from 2011 to 2016, we have published more than 280 journal papers, 430 conference papers, and have been granted 49 patents, which are US, PCT, Japanese, Korean, and Indian patents. So this sort of indicates to everyone that this is a very vibrant, active research department. Coming to the academic programs which you may be interested in. So this is MTech in communication networks, MTech in signal processing, MTech in microelectronics. It's a 4-semester course. And students who pursue these MTech programs can also avail possible enhanced scholarships offered by Texas Instruments in the field of analog design, where students will be mentored from employees or research scientists from TI and IISc, and also can do internship in Texas Instruments. So this is one such program which offers enhanced scholarship if you want to pursue analog design. And internships are allowed for all MTech students during May to July before the 3rd semester, that is after the end of the first year. Students can go and do internships, and typically internships could be in Intel, Qualcomm, Microsoft Research, and companies of that kind, which may also help in students securing a job at the end of the master's program. We also have a provision for MTech students to convert to PhD program after the end of the first semester if they have a reasonably good performance and motivation to do PhD. So the placement last year, that is the year which is going to graduate in June of 2017, companies like Qualcomm, MediaTek, Infosys, Juniper, Samsung, Analog Devices, Intel, MaxLinear, Netterdyne. Basically, these are companies which are a combination of startups and established companies, have offered jobs, and the average CTC offered for MTech students in 2016 is about 14.6 lakhs per annum. So this is what students would get if they complete the MTech program successfully and get a good CGPA, which is, I think, and it is in some sense a reflection of the training which the MTech programs offer to students, that the top companies make a good offer of jobs for you. If you're interested in the research program, then there is an MTech research program which is about 2 to 2.5 years, and then the PhD is about 4 to 5 years. So we have several possible enhanced scholarships and incentives for participating in joint collaborative research programs. So for example, the company Thales offers one PhD scholarship to a student who can visit a university in France with joint supervision between faculty in a French university in IISc. This is for a 1-year stay in a French university. We have a collaboration between IISc and TU Delft of Netherlands, which offers 3 months visit to TU Delft from the 3rd year of their PhD onwards, and joint supervision between faculty of TU Delft and IISc. The degree will be offered by IISc in both cases, but the student can collaborate and interact with research groups across the universities. And all PhD students can do an internship of about 6 to 12 months in universities abroad or in industry, and enrich themselves and maybe even find a good research problem to work on. So the institute, the department is basically quite active in industry collaboration. So some of the names with which faculty members are involved are all the companies like Analog Devices, Boeing, Bosch, as you can see on the slide, Ericsson, Honeywell, Qualcomm, Volvo also, Nokia, and so on and so forth. So students can benefit when the faculty member has a research interaction or a project with any one of these companies in their respective labs. Our alumni are in almost all the top leading industries across the globe, starting from Analog Devices, Applied Micro, ARM, Bosch, Broadcom, CDOT, and so on and so forth, Qualcomm, Xerox, TI, and so on and so forth. So this is basically an indication that the training a student gets either through the MTech program or through the PhD program basically enhances their technical knowledge, induces a sense of problem solving which are relevant to the industry, and the industry is very happy to have them, and many of them have risen to top administrative and technical positions of these companies. And several alumni after graduating either MTech research or PhD have also gone to various top universities in the world, which include all the top schools, as you can see: Stanford, MIT, Georgia Tech, Urbana-Champaign, Southern California, and so on and so forth. And these universities have also not just provided the opportunity for them to do their PhD, but also many of them have joined faculty positions in top schools, so including University of Michigan, Berkeley, and so on and so forth, UT Austin, and so on and so forth. So as I mentioned, we also have some deep international linkages with India and France, India, UK, Indo Swedish, and some Australian universities also are involved. So these are project through project where collaborators from universities in those countries and in IISc are working jointly on a certain research project and deliver deliverables across, where students and project staff can go and visit the other universities, spend some time, and researchers from other universities come and spend time in the department. So we have a nice collaborative activity. So very quickly, I would like to go through the various activities which the department carries out in terms of research. So we pursue theory and practice. So if you are familiar with the equations what are being displayed, then you are in the best position and to join this department. If you are not, then you are still in the best position so that you can learn about it. Next. So very quickly, I will run through the slides. So we have a very strong initiative in 5G. You will hear maybe about it or related to it maybe after my presentation. So 5G, as all of you know, is going to be the next generation wireless communication technology, where you will be trying to do a lot more than what you experience in 4G. So you will have to use new techniques and technologies and ideas and new frequency bands in order to deliver what you would like to see as a user, which may include a 1 gigabit to 10 gigabit per second per person self-managed networks. So it's a very exciting futuristic area. The standardization will happen or will conclude in 2020. So if you join now, you will be in the right time frame to actually contribute to maybe new ideas and techniques which may go into the standards. So this is a very exciting time for students to pursue this field of 5G technologies and all the technologies contributing to making 5G a reality. Next. So we are very active in Internet of Things, IoT, so where a lot of sensor network activities are going on, and which includes deployment of sensor networks for various applications. We have a vibrant speech and audio signal processing activity, which includes human-robot communication, microphone arrays, speech and signal and audio signal processing, and a lot of image processing also, where we would like to see and define quality of images, and research work is happening, which may also lead to virtual reality and other interesting, exciting technologies. This field of sparse signal processing is a very powerful tool which has transformed signal processing over the last maybe 10 years, but it's now really hitting almost all applications which are possible using this tool. So this is another field which is very exciting, which students can pursue. So very hot field of nanoelectronics. So faculty members do work on in this topic, in building nano devices, looking at building sensors, and so on and so forth. So we have a world-class facility on campus where students and faculty members can use it. It's a national facility, so people can use and actually build chips, maybe make new sensors, or even invent new devices, or discover new physical processes or effects in the field of nanoelectronics. So a lot of activity in RF and microwave research, so like antenna design, building RF devices, and in 5G we may have to go to millimeter wave technology, so a lot of interesting possibilities of doing research in RF and microwaves, and computational electromagnetics. Next. A lot of work in photonics, where you can do new devices, and also in optical communication, using Raman effect spectroscopy. You may build microscopes, new devices, and understand various things, right from biological tissues to anything which you want to do using optics. VLSI also is a strong area of interest in this department, where you can build digital VLSI circuits and analog VLSI RF chips, where you can build sensors and low power. All of you must be familiar that we need to develop low power technologies so that our batteries last longer on our smartphones, and we can do much more than what we are doing right now. So what do we deliver? We deliver world-class researchers, whether you are an MTech student or a PhD student. We believe that we would like all of you to go through a process and a training which will enable you to think differently, think beyond what you know, think out of the box, and we provide you an opportunity for you to explore yourself, challenge yourself, and produce excellent quality of publications, patents, and prototypes. And you will be assured of going through an excellent teaching program, which will be a unique program. And on campus, this is one of the most unique campuses where you will be able to learn across departments in various fields and topics of your interest, and which will make you a better engineer and a better researcher, and hopefully will contribute to the technology landscape, providing global impact. Thank you very much, and I will now request my colleagues to continue this program, and I wish you all the best, and I look forward to your applications and hopefully joining our department. Thank you.
Thank you, Hari, for that nice overview of the department and all the activities that we do here. This is what it takes, this kind of stuff is what it takes to get us in the ranks that you see in those newspapers. We now have the faculty who are present here to say a few words about their own research areas. So Hari already gave an overview of the broad research areas that the department works in. Now we'd like to get some perspective from the faculty members themselves. I'll first start by requesting my colleague Dr. Rajiv Soundararajan to start describing his research area.
Hi everyone, I'm Rajiv Soundararajan. I graduated from UT Austin in 2012, and I've been an assistant professor in the ECE department since October 2015. I work in the area of signal processing, and in more particularly in one of the application areas of signal processing in image and video processing. And to give you an idea of where image and video processing is typically used and very popular today, there are at least 3 broad areas that one can think of. If you think about it, today most people are online watching videos, particularly this YouTube session is also happening online. People are on Netflix all the time, and in all these big scenarios, there are hundreds of servers of videos that have to be stored, analyzed, processed, and delivered through communication links. And so I work in the area of trying to quantify user experience in such scenarios, and how you can manage all these videos on these servers and deliver them such that the user experience can be maximized. Another area that is very popular today is with respect to image processing is that most of the time when you buy smartphones, the one parameter that kind of determines why you buy what phone you buy is typically the quality of the camera that's in the smartphone. And typically you always compare different cameras. You probably try to say that Apple is better than Samsung and so on, or vice versa. So I primarily work in, you should note that when you have cameras on smartphones, there are sophisticated image processing algorithms that run on the smartphone to try to produce the high quality pictures that you finally see. And one of the areas that again we work on is in trying to come up with the best image processing algorithms that can produce high quality image pictures that with quality that equals that of expensive SLR cameras and so on. And a third area that we are beginning to look into in the department is in the area of virtual reality. So typically, if you had noticed recently, head-mounted displays are becoming increasingly popular. A lot of people are watching virtual content by using these head-mounted wearable devices. And one of the problems that we're trying to work on is to try to understand user experience in such scenarios, to try to see how we can deliver better content in such systems.
Thank you, Rajiv. So for all of these descriptions, if you want more details, you are welcome to visit the websites of the faculty members. They'll typically have a much more detailed overview of the research, including the publications that have come out of this research. Now let me pass on mic to my another colleague, Professor Chandramurthy.
Thank you, Himanshu, and thank you all for those of you who are watching this video chat session online. So I'll talk a little bit about signal processing for 5G applications. One of the things, as Professor Hari mentioned about 5G, is that it will have to cater to a variety of applications and typically has to deal with high dimensional data. And so in order to optimize such 5G communication systems, it is necessary to deal with high dimensional data and to run analytics on such data, discover structure in the data, and use that structure to optimize communication systems. So we are working on many aspects of such optimization of communication systems using signal processing techniques, and in particular using sparsity-based techniques in the Department of ECE. So signal processing algorithms typically stand on 3 pillars: theory, algorithms, and applications. So we are interested in new novel applications of signal processing in 5G, in the context of 5G. And for those novel applications, we will develop new algorithms. And we are also interested in understanding how well those algorithms perform. And to that end, we theoretically analyze the performance. And for this, we will use, or we do use, tools from data analytics, Markov decision theory, optimization, etc. And a variety of mathematical tools are used for such problems. And finally, we also want to look for algorithms that are fast, that consume low energy, that can be parallelized, can be implemented in a distributed fashion across servers, and can deal with very large dimensional data. So all of these are very fundamental problems of interest, and therefore solving such problems not only make you an expert in communication systems, but also an expert in fundamental signal processing techniques, which make it possible to get jobs in all kinds of fields, not just limited to communications-related companies. So thank you for the opportunity to share some thoughts with you, and wish you all the best.
Thank you, Chandra. Next, I would like to request Professor Parimal Parag to say something about his research.
Thanks, Himanshu, and thanks to all of you who are watching. So I'll talk mostly about the data networking today. So data over network is a, I would say, a more recent phenomenon and very popular these days. So most of you must have seen at least 3 kinds of data. One is your personal data, such as email, private documents, your files and photos, etc. So these are stored on cloud services provided by Google, Facebook, Dropbox, GitHub, etc. So the main challenge in storing such kind of data on network is availability. You want to make sure that wherever you are, you're able to access this data on whichever device you're using to access. The second kind of data which is popularly used these days is content, which is disseminated across a large number of people over internet. For example, streaming video, music files, data sets, or a software which you download. These are managed by YouTube, Netflix, Hulu. And the challenges here is scalability. You want to make sure that if a lot of people are interested in your content, they are able to access it. And you want to make sure that this happens with low latency and there is a high availability. The third kind of data, which is information that needs to be processed. So this is more for enterprise or special companies. For example, you're collecting maybe machine logs from your app and you want to use it to improve the performance of your app. Maybe you have some health data from the hospital and you want to make some analytical decision based on it. So these kind of data is stored on a platform provided by big cloud services such as Amazon Web Services and Microsoft Azure. So there are many interesting questions in this domain, and some of the fundamental question being how and where would you store the data? Or if you're doing a cloud computing, how do you compute these interesting analytical questions on these distributed machines? Then there's a new paradigm of data networking which has not come to realization yet, but this is what we are looking forward is IoT, where you might have hundreds and millions of interconnected devices which have some intelligence inbuilt. So they have some, and they can also communicate with each other, maybe talk to a cloud server which can do analytics for them. So how much do you communicate with them? What should you communicate with them? What information should you get back from them? And what kind of control do you need to, what kind of decision you need to make once you have this information available? So these are the other set of questions we are trying to address here at IISc. So that's all I have to say. So I look forward to hearing more from you guys. And if you have any questions, please type in the chat. Thank you.
Thank you, Parimal. Next, I would like to request my another colleague to talk about his research area.
Hello, my name is Varun Raghunathan. I'm an assistant professor here in ECE department, and I work in the area of photonics. So I just wanted to give you a quick overview of what all research we do in photonics and what is the potential future prospects for doing research in photonics in our department. So there are mainly 3 faculty who work in the field of photonics here, Professor T. Srinivas, Dr. Kaushik Majumdar, and me. And so our areas of research span all the way from optical communication, quantum communication, and also building basic devices, like fabricating these devices in the clean room, and also applying optical effects to study building interesting sensors, novel sensors for defense or space applications, and also to use light and optical effects to essentially help biologists in looking at biological samples better and those kind of problems. So very briefly, in terms of the hot topics of photonics we work in, quantum communication and application of that is a hot topic, and Professor T. Srinivas works in this area. And there's also interest in 2D materials, like novel materials with which you can build optoelectronic devices, more in particular like building photodetectors with very high response, very high efficiencies by using novel 2D materials. And my group has been interested in building nano-photonic devices, like integrated optical devices for sensing applications in the longer wavelengths, like in the mid-IR type wavelengths, where there would be interest in probably from a defense or a space point of view. And in terms of future prospects, I think there's a lot of good opportunities, previous students who have gone through this photonics program have either been placed in the industry. For instance, GE Research would be one place where photonics professionals are hired. And there's also more like government labs, like ISRO labs and other places also. We have other ECE alumni. And also with a strong foundation in photonics, with a basic MTech program, there's also good prospects to go abroad and do your PhD and more advanced studies in this, and also postdoc if you happen to complete a PhD here. So in general, photonics is a very interesting topic, interesting area to be working in, and there's a lot of interest among the faculty to be working in these areas. And people who are interested in more hardware type projects, I hope will consider working with us in this field. Okay, thank you.
Thank you, Varun. So this was just a small sample of different kind of research activities that we undertake here in the ECE department. And of course, this is just a tip of the iceberg. If you want to get a bigger picture, you should go to our department website and check out the profiles of different faculty members and the kind of research program they have. And also beyond the ECE department, the research experience here is quite rich, because you typically interact with not only the ECE department, but other departments which are working on areas closely related to ECE, for instance, the computer science department and the electrical engineering department, and DESC, which is the systems engineering department. We now open the floor for questions. If there are some questions from the audience, they can type it in the chat window. I also have a list of questions with me which are from previous year students, and they sound quite relevant to us, so we'll take up those questions. Should I start with this one? So, Parimal, can I request you to come? So I'll pass on the mic based on who I think can best answer the question. So let me start by taking up this question, which is about how would the MTech degree add to my job perspective? So the question says that how will an MTech degree help me in getting a better job if I already had a job offer in my undergraduate? So this is a common concern for many students, that if they have a job offer after their undergraduate degree, what extra value addition would an MTech degree give them? So let me invite Parimal to answer this question, because he has 3 years experience of working in a high-tech startup after his PhD, and he can shed some light on this question.
Thanks, Himanshu. So, I mean, I can only tell from my experience, and everybody's experience is different. I think it depends on what your job profile is. If you're getting a job where it challenges you intellectually enough at the undergrad level, and then you think you can keep growing, this is well and good. What MTech at IISc will offer you is a different job profile. When you graduate and leave, and then you go back and join industry, the kind of work you would be doing would potentially be completely different than the kind of work you would be doing after undergraduate. So industry in general does not give you responsibility right away. Unless they think that you're ready for a job, it will not be, so you'll have to earn it. So in some sense, this MTech is this earning degree. So when you go back, and then you'll be working on, much more interesting problems. So that's what I think. So maybe others can add a little bit more. Thanks.
Yeah. So just to add to what Parimal said, I just like to reiterate that if you go to industry after obtaining advanced degrees, and like an MTech degree or a PhD degree, the kind of problems that you get to work on are much more exciting and have far-reaching consequences and impact, as opposed to the kind of problems that you will get to work as an undergrad in industry. So that's where I think the real difference is between just graduating with a bachelor's degree and taking up a job, as opposed to taking up a job after an advanced degree. You also get the opportunity to work in high-class research labs and advanced engineering problems in the industry with an advanced degree like MTech or PhD.
Yeah, so one more thing I would like to add is so you should not just think of the job as a 2-year thing. So job keeps on going, and you should think of building a career. So if you have an advanced degree, it will help you also in the long run. How you'll progress in your career depends a lot on, if you have an advanced degree, it definitely will help you in the longer run. So, thanks.
Okay, so after you are done with your MTech degree, or let's say the PhD degree here, one option is to go to industry. The second option is to join academia. And in that context, one question that has been asked is, what are the job perspectives for academic jobs after a PhD, especially in India? So let me start by adding from what I see, let me add my answer to it, and then we'll take a response of others. The government has built up several new IITs, and you can go and check their websites. Typically, they're all in hiring mode. And you'll be able to find an IIT close to your hometown. And the graduate students are the most coveted faculty for these IITs. Okay, if you go to any new IIT, they would like to hire people from IISc, and that's because of the kind of research program that we run here. And so when you come to IISc, you'll be potential candidate for these IITs. Also, after your PhD, sometimes people don't directly apply for a faculty position. They go for a postdoc research experience, which is either in India or outside India. And our alumni have typically got postdoc offers from the leading universities of the world, including MIT. That's what comes to my mind from recent time, but Berkeley, other places, all over the place. Typically, we get postdoc offers from the best leading institutes in the world. Okay? That was the second question. Would you like to add on this? Would you like to add on this? Job. Okay. So there were some questions asked on the live chat window in context of some logistics. There were some questions asked on the live chat window in the context of logistics. Someone has asked, can an undergraduate from IISc enter the MTech program in ECE? And yes, of course, they can enter the ECE program. The rules are, I don't remember them off the top of my head, but it's easy to apply for this program.
Undergraduates from IIT don't need to take GATE as such to enter the MTech program. Is it the MTech or the MTech program? No. To enter the research program, you don't need to have a GATE score if you're an undergraduate from IIT, provided your CGPA at IIT is at least, I believe, 8.5. I'm not sure of the exact rule, but you can check the website. It'll tell you the rule. Undergraduates from IISc, yes, yes, they can apply. They'll be treated like at least like an undergrad from IIT. So.
So the next question, can I take courses from other department? Do we have options when selecting courses? Well, IISc offers one of the richest variety of technical courses, research-oriented courses in the country, and there are several departments that you can access when you're looking for a choice of courses. For instance, for our department, typically people take courses from the mathematics department, computer science department, electrical engineering, DESC, which is systems engineering department. So several courses. You'll have a huge selection of courses to select from. Do you want to? Is there something to it? And the program has several electives. There is a component which is core, but there is an elective component to the program. So you'll be allowed to choose between the. You'll have various options when you're choosing your courses.
So in case you're a research student, the courses you take are essentially based on what research topic you might be pursuing. If you're a master's student for a course program, you have some core courses, either they're hardcore or they're softcore, and there is a fair amount of flexibility in terms of electives. For instance, in the MTech Communication Networks program, you have a flexibility of doing a minor in various other topics such as signal processing, RF and microwave, photonics, and so on, microelectronics, and so on. So you can mix and match quite a few, a variety of courses. So the MTech Communication Networks program has as an implicit major the communication networks topics or courses. These other courses are minors, or they're free electives, which can be from anywhere in the institute. And there are certain courses like MTech Microelectronics which don't have even a fixed set of hardcore compulsory courses, but they offer you a choice in even the softcore courses that you take.
So basically, in summary, there are several options. You can apply for a major, you can apply for a minor along with that major degree. And major is typically fixed by the program that you apply for, and a minor you have flexibility based on the course requirement that you complete. Okay, so let me take this next question, which is from Mr. Peter Morris. And his question is that, can we apply for a PhD? I'm rephrasing the question. This is what I understand from the question. His question is, can we apply for a direct PhD after an undergraduate degree? Or should we come through the MS or MTech, MTech or MTech research route? Well, we do allow direct admissions to PhD after undergraduate for exceptional students. And they just have to clear GATE, but typically the academic record should be exceptional. But also many students come for an MTech program and convert their MTech degree into a PhD degree. That is also something which happens very routinely here. And MTech research, which is a longer research program, from there also you can convert to a PhD degree. So all three options are valid. And you can decide. And in fact, there is no harm in if you're directly applying after an undergraduate degree and you strongly feel that you want to do a PhD right away, there is no harm in applying for a direct PhD. Okay. The next question I want to take is from Mr. Hari. And he says that he has done his BE in instrumentation and is interested in doing MTech in signal processing. And is he eligible to do that with a valid gate score in instrumentation? And so for signal processing, for MTech in signal processing. Yeah, yes. So yes, it seems that it is allowed. For MTech research in SP, a gate score in instrumentation is allowed. So yes, you can apply for MTech research. That's what you were asking for. Let me see. Questions which are directly relevant to admissions here, although some of the other questions are also very interesting. Maybe call for a longer discussion. Okay, so the IISc website has gate score cutoffs for eligible gate exams, and you can just go there and take a look at that. And there, by the way, I also, if you are in the Bangalore area, I welcome you to come and visit our department and have one-on-one interaction. Some of the questions that are being posed are very specific, and I would not like to take them up on this forum. You are welcome to visit the department, and some of the questions are also relevant when after you have joined, in the sense that there are a lot of questions about internships and the rule for internships, and these are specific to your advisor and the program that you have joined. So that's why I'm not giving a direct answer for this. So I'm skipping these questions. Let me take up one more question from last year. These are the questions that we collected last year in a similar interaction. So this is the question about how is the area and advisor for my MTech project assigned.
So I presume you're talking of the MTech by course work, and you do a MTech project as part of it. Typically what happens in our department is that, so it's a four-semester program, and at the end of the first semester, you are assigned a MTech project guide. That assignment is based on students' preferences and faculty availability, so what happens is that the faculty put out a list of projects that they would like students to study or work on, and the students meet the faculty after that and discuss their interests and the projects that faculty suggest, and the student gives list of preferences after that regarding which faculty members or projects that they want to work on, then there is some kind of a procedure by which the allotment of guides to students takes place. So very often it turns out that students do get their first choice of guide, and everybody is happy. So the project areas are of course usually relevant to the MTech program that the student is enrolled in. Although for instance, as an MTech microelectronics student, you might be working on something that has to do with communications also, or an MTech communication student, communication network student may also have some hardware implementation or microelectronic development as part of it, depending on the faculty member who is guiding the project.
So thank you, Utpal, for patiently describing the process. Utpal turns out to be in charge of this part in the department. So let me conclude this event with a final question about the student life here. And the question is, how is the student life experience in IISc different from the experience that people typically have in an undergraduate university before coming to IISc? And of course, I've rephrased the question a little bit. And for this answer, I would like to invite one of our PhD students, Karthik, to describe how has his experience been different in IISc as compared to his undergraduate university. Maybe you can also describe where was the undergraduate and what is the difference. Okay.
Okay, hello all. My name is Karthik and I am a second year PhD student here working on information theory, and I completed my undergraduate program at RV College of Engineering and I graduated in 2014. So the experience here is like really good. So there is a very huge diversity of courses that IISc has to offer. And as Professor Himanshu Tyagi mentioned earlier, there are absolutely no restrictions, especially in the research program where a student typically takes courses that are streamlined to his or her research. You get to take a lot of courses from various departments that have to offer subjects that are very particular and pertinent to the area in which you are working. And so just to share my experience, I have actually taken courses from the math department here, apart from ECE, of course. And then, in fact, the same course will be offered in various departments, and depending on the flavor in which you would like it, you can choose to attend the course in either of the departments or perhaps in both to get a varied perspective on the same subject. And then when it comes to interacting with the faculty members, so we would not have gotten to interact with faculty members who hold their PhD degrees in extremely good institutions abroad. And I would like to say that it's a privilege that we have we have top quality faculty members here at in the Department of ECE, and almost all the faculty members are very open to discussions, and it is in some sense encouraging the students. It is in the spirit of encouraging the students to pursue interdisciplinary research, if you really ask me. And then there are also options to apply for a variety of fellowships that will encourage you to work on something that will be outside, that will allow you to think outside the box from whatever research you are carrying out. And then these also in some sense strengthen the rapport between the faculty members and the students, because you would get to interact with many faculty members who will be on your who will act as members who will be guiding you for these fellowships and things like that. So yes, all in all, it's an excellent, we receive high quality training here. It's an excellent experience to be in one of the topmost departments here in IISc. So yeah, that's all I have to say. I hope many of you will come join us here. Thank you once again.
I assure you it was not a planted answer. It was actually, I just asked it. But so let me just conclude by adding that besides the academic environment, which is quite good, I have myself experienced 2 other universities across the world, and this to me is at par with the best places in the world. There is a lot of social activity happening on the campus. The campus has many facilities, including a gymkhana, and there is an undergraduate program because of which you see also an annual fest now. And along the same lines, we would invite young among you to come and join us, at least apply to us, and add to the vibrant culture of IISc. And with that, I think we'll stop the... Okay, if you have any additional questions, you could write to us. You can find email addresses of our chairman or the office at the ECE website. Or you can go to, as I said, to our website and get a lot more information about the department than what we were able to cover in this short broadcast.